Let's recall our work with multiplying by brackets. One of the types of questions that we were looking at most recently was something like what I've written here, 3 times 4x minus 5. We showed, using a diagrammatic approach with tiles, that 3 of the 4x minus 5's could be really written as 4x minus 5 plus another 4x minus 5 plus another 4x minus 5. That the three 4x minus 5's really meant just that. For that reason, we could simply go ahead now and group our like terms and find an expression that represented the final answer. So we notice here that we've got x terms and we've got constants. We know that the x terms can be grouped together. So we have 4x plus 4x plus 4x, or 12x. And we can also add our constants together. So minus 5 plus minus 5 plus minus 5 could give us minus 15. When we looked at this last, however, we also examined a diagrammatic approach, which I really like. That diagrammatic approach said that we have 3 of the 4x minus 5's. And what we were able to do is just take this style of representing our thinking to a slightly different way. We said that we have 3 of the 4x's, which gives us 12x, and we have 3 of the minus 5's, which gives us minus 15. Notice that still gives us our answer, 12x minus 15. Just a slightly different way, perhaps, of visualizing or communicating our thinking. I want to show you yet another approach that you might want to consider. If I have the same question, 4x minus 5, sometimes, well, perhaps even some of you in the past may have been shown this, and so that's why I thought I should connect it. Some people may have used an arrow to show that this 3 actually applies to each of the terms inside the bracket. It's really the exact same thing we've been doing in the previous examples, but this is just representing it in a slightly different way. So the 3 is being multiplied by the 4x, and the 3 is also being multiplied by the negative 5. The way that this may seem familiar is that now we have monomials that are multiplied together, and we just did a little bit of work with multiplying monomials. We said that we would take the numbers in front, the coefficients, and multiply those, and then multiply the variables as well. So in the first situation, we would have a 3 times a 4x, which is 12x, and then we had a 3 times a negative 5, which was negative 15. Now we notice that we're having 12x plus negative 15, that's a little bit cumbersome. So we could, of course, rewrite this as simply 12x minus 15. So we notice that the 3 different ways to visualize our thinking and communicate our thinking, of course, give us the exact same answer. You're able to choose whichever one works best for you. Now, we've been calling this multiplication or multiplying with brackets. Something else you might see this described as is using the distributive property. This process by which we take the number out front and apply it to everything in the bracket following, that's sometimes called the distributive property. And if you think about the word distribute, if someone is wanting to distribute a handout to everybody, it means that each person has to get that handout from the person who's distributing it. In this situation, this is the distributive property because each part of the following bracketed expression must have had the 3 distributed to it. Let's consider another example together. I could ask you to multiply this single-termed expression, this monomial, by this binomial. I could also ask you to expand, then simplify the expression. When you see those types of directions, it simply means that you're going to multiply and then group the like terms. Let's start by drawing a diagram. So we have our 2x that's multiplied by 3x and plus 4. We know that the 2x applies to everything inside of the brackets. And here's where we get to apply our thinking related to multiplying monomials. So to form the first entry, it would be 2x times 3x, which will give us 6x squareds. And then we have 2x times 4, which is going to give us 8x. So in this situation, our answer would be 6x squared plus 8x. That's using the first approach that we looked at just recently. Let's look at the second way of thinking about this using the arrows. So we said that the 2x must be distributed into the bracket using multiplication. So the 2x is multiplied by the 3x, and the 2x is also multiplied by the 4. Now, using our rules for multiplying monomials, we'll multiply the first coefficients, 2 times 3, which will give us 6. And instead of writing that as x times x, we said that we could use a power. The term that's being multiplied by itself is the x. Since the x is multiplied by itself twice, we have a little exponent 2. In our second part of our answer, we multiply our coefficients, 2 times 4, which is 8. We have our x, but we don't have anything else to group that with. Now, at the end, I'm always looking to see if I can simplify the expression. I notice, just like above, it's the same answer, but I have an x squared term and an x term. Of course, I recall that I can't combine those like terms because although they have the same variable, they do have different exponents. So that's the most simplified form of the expression that I can actually write. Let's give this example a try. I want you to copy down the question, pause the video, try the question, and check back when you've had a chance to think it through. Let's show both ways of thinking about this one more time. So we've got our negative 7x that's going to be multiplying the 4x minus 1. We know the negative 7x applies to both of these. Now the only thing that's different here is that we need to remember that we have negatives and positives here. So we've got a negative 7 and a positive 4x. That being the case, we know that a negative times a positive is going to give us a negative. In this case, it'll be negative 28. We had an x times an x, so that's x squared. Let's take a look at our next two terms. We've got still the negative 7x, and this time we have a negative 1. So we will recall that a negative times a negative is going to give us a positive. So negative 7 times negative 1 is positive 7, and we have an x there. We could write our answer as negative 28x squared plus 7x. We said that our second approach could be to use the arrows to show the distribution that was occurring as we expand. So I'll write in the arrows that show that we're using this distributive property. And now we would take and just multiply everything inside the brackets by the negative 7x that was out front. So we had negative 7x times our 4x, and then we added that to negative 7x times our negative 1. So let's use our rules for multiplying monomials. Multiply the coefficients in front. Negative 7 times positive 4 is negative 28. Instead of writing it as x times x, I'm going to write it as x cubed. Our next bit, we have negative 7 times negative 1, which is positive 7, and x. We don't have any other variables to combine it with, so I'm just going to write it as x. Notice that both approaches gave us the exact same answer. It's not necessary to do both approaches. I'm just showing you both approaches so that you can choose the one that works best for you. Here's a final question that I'd like you to try to challenge yourself. Copy it down, give it a try, and check back when you've had a chance to do so. This time I'm going to change the order of the types of solutions that I'm going to show. Let's start first by using the arrows to indicate that 3x is being distributed to each term inside the bracket. Now notice that there are now 3 terms. There's a trinomial inside the bracket instead of a binomial like the other examples, but the process is still going to be just the same. So let's write out our expanded form. So we've got our 3x and our 4x squared. We'll add that to 3x times our 5x, and we'll add that to 3x times -1. Let's talk about how we're going to simplify the first part of this, so the 3x times the 4x squared. So if I wanted to, I can think about that as being 3 times 4 times x, and then another x squared, which I could write as x times x. The next part I could write as 3 times 5 times x times x, and of course the last bit I can write as 3 times -1 times x. Now this is a step that we might not need. I think many of you will be okay without including this step. I'm writing it in here just for clarity. So we've got our 3 times our 4, which is our 12. Now this is the real reason I wrote that step out, in addition to clarity, is that we've got an x times an x squared. Notice this means that we actually had 3 x's multiplied together. So instead of writing that as x times x times x, we can use a power to express that multiplication more concisely. Since the x is being multiplied by itself 3 times, it will have a little exponent 3. Let's take a look at the second part of this expansion. 3 times 5 is 15. I can write that as x squared, and I had a 3 times a -1, so that's really going to become minus 3x. Now something else you might have started to notice here is that a really quick and efficient way to figure out what our exponent will be on our power is that I can look that I have 2 x's multiplied together here. I have 1 here. If I add those exponents, it gives me the exponent on my product. Now the only thing to remember here is the only way that works is that if it's the same base, if it's the same variable that's actually being multiplied together. So if this was an x and this was some other letter, that idea of adding the exponents would not work, but it works in the cases that we're dealing with here. Let's finish up by writing this using a more diagrammatic approach for those people who enjoy that. So we've got our 3x, we know we have a 4x squared, we have a 5x, and we have a -1, and we can go ahead and write in what we know to be our products. So 4x squared times 3x is 12x cubed, 3x times 5x is 15x squared, and 3x times -1 is -3x. So we can write our final answer as 12x cubed plus 15x squared minus 3x. And notice that is the exact same answer as what we got using the arrows approach and showing the distributive property that way. One last thing, notice that we are not now grouping any of these 3 terms in our trinomial. Even though they have the same variable, they have different exponents. Of course, the exponent on the last term is really 1, therefore they are not like terms and they cannot be grouped.